Dementia is an incurable disease. Dementia patients rely on community nurses to manage medication. But living in the world of COVID-19 often means that healthcare staff are unable to regularly visit patients. In Australia alone, over 400,000 people are afflicted with dementia. A decline in cognitive ability negatively impacts the patient's ability to organize and consume medication on a routine schedule. Additionally, prescription medication is often placed in blister packs that elderly dementia patients may struggle to open. At Team Mentia, we believe in helping dementia patients to live their best life. That's why we've designed the ultra-revolutionary Pill Dispenser 3000. Our product not only dispenses the medication, but also informs the patient. The automated system incorporates a dual sensor design that guarantees consistent dispensation. It also checks if the patient has taken their medication on time to give them the extra peace of mind.
So I've got the overall design of our setup here. So the pill dispenser has 4 main sections. So we've got the time and alarm setup, which I'll go through shortly, our output signal area, our LEDs, which indicate what mode the state machine is in, and our input forces and PIR sensors. So in setting up the time, just like a normal clock, we use our plus minus buttons here. And then if we want to shift to the next mode, so whether that's the minutes or setting the alarm, we hit this third button across. We can also go back to check the time that we've set. But once we go into our 4th mode, the very last one, that locks us into our idle state. We then got to turn on the machine. So this goes from a 0 state to a 1 state. Then once we have our alarm matching our real time, it goes into the 2nd state, and that would force a motor to turn the pill to drop onto this scale here. If no pills dropped, so for instance we've run out of pills, the force sensor doesn't witness any electrical current, doesn't output anything. And so after a certain amount of time, it would go to a fault state, and at that point then it would notify the caregiver. Okay, so let's just assume that the pills dropped. So the pills dropped, we now go into an alarm state. So it alternates between these 2 states here, so 4 and 5, and it tells this PA to turn on and off, making an alarm noise, and this LED for more visual people that their dispenser is going off. So if you wanted to turn this sound off, we do have a silence mode incorporated into the design, so that involves this slide switch here, which will turn it on and off. In terms of retrieving the pill, this is another fault state that we have. So if you don't retrieve the pill after an extended amount of time, whether that be an hour or so, then it goes into another fault state, sends a message to the caregiver saying, look, such and such hasn't received it. In terms of collecting it, we've got a double access system, I guess. It needs to pass these 2 tests. So we've got our infrared sensor, which is like a door, I guess. You can open the door, your hand goes in, you pull the pill out, the door closes. So in that motion, it detects whether the hand has gone through or not. And then after it detects the hand's gone through, it does a check on the scale. And if it's taken the pill off the scale, then it's assumed that the person's consumed it. If it doesn't get taken off the scale, then we continue that alarm. After it does a good pass, we go into this wait time, which as you can see here, we go from taken being a cross to being a tick. And then when it clicks back over the midnight, this all resets. So we go back to that idle state.
The final iteration of our team's state machine was developed in a way that allowed us to achieve the desired outcome with the limited components we had available. What this means is that while some excess parts were used, these excess parts can be simplified down. For example, our state machine implements a makeshift decoder which was constructed out of 5 components. Normally, a decoder is a single component, but due to limitations, our decoder could not be. As such, if our product was to be furthered, this is one example of a substantial change we could make. This is a nice segue into future additions for our product that could be included at a later date. The first addition would be the inclusion of a sensor to help detect when the dispenser was empty of all pills. When the sensor detects this state, a message could be sent to a party approved by the dispenser owner to notify that it needs to be refilled, with a message also being displayed on the dispenser's LCD display, indicating that the refill needs to take place. The second addition would be the inclusion of more sensors to verify whether or not pills have been dispensed and taken. This could be achieved through a small camera that takes snapshots of the area the pill dispenses into when it has detected a pill has been dispensed and when it detects if a pill has been removed. The final addition would be the inclusion of more dispenser sections. This is because currently our design can only dispense a single pill type. With this inclusion, our product will become more viable to patients that require more than one type of pill, allowing us to reach a broader market and be used in more situations.
Our marketing strategy is to start producing our product for hospitals which can use it to help their patients, also looking into companies and organizations that focus on the medical side. Selling it to these companies and focusing on these organizations by providing them some samples of our product will result in a positive payback time for the team while also benefit the community and users of the device.
The most important aspect of our product's marketability lies in its uniqueness. Our dual sensor design not only guarantees consistent dispensation, but also checks if the patient is routinely taking their medication. Similar products on the market either do not support this feature or charge excessive fees. We believe in the affordability of our product, and that's why our dispenser is just a one-off purchase. This is what sets us apart, and it is expected to dramatically improve its attractiveness to potential customers.
This section deals with the profitability of the product. Although the labor cost estimates did not change much, but the price of the actual product changed from $101 to $136. The team thinks that this change in price does not affect the product as much because for now our product is very efficient, and we believe that the profitability of the product lies in how efficient and easy to operate the product is rather than the costs. To conclude the video, I'd say the product does seem like a profitable idea. It helps the society by assisting caregivers and dementia patients. It does solve the problem that was presented to us, and we think that if we can incorporate the ideas that are presented in the video, in future the product could be more pragmatic and it could be improved. Thank you.